Okay, the point of this video is to talk about using a UBLOX GPS unit as a variable frequency signal source and some of the limitations in doing so. Before I get into it, there's another video out on YouTube that does a very fine job of detailing what this is all about, and it gets rather technical, and but it's a long explanation that I highly recommend if you're really interested in this topic. This video will likely be shorter, and it's really intended to just kind of demonstrate what's going on with within this GPS unit when you dial in various frequencies as output signal sources, output signal waveforms, using UBLOX U-Center software to change the default output, which is a 1 pulse per second output out of the PPS pin on the unit, to frequencies all the way up to 24 megahertz. On board the UBLOX unit is a 24 megahertz oscillator, and the only frequencies that you can get out of this unit without jitter or without glitches, in other words, pure trains of square waves that are all identical, are frequencies that divide evenly into the 24 megahertz oscillator frequency. So that's what I have on this spreadsheet, is a list of all 140 factors into 24 million, if you will. And I got that from a website. Let's see, that's this one here. Right, so it's just a factoring calculator online. I just put 24 million in there for the 24 megahertz and click calculate, and it spit out the 140 factors of 24 million. So that's where that spreadsheet data came from. I just copied it from that web page once it was generated and pasted it into the spreadsheet for convenience and for reference. So the factors, obviously you have 1 and 24 million, 2 and 12 million, 3 and 8 million, on and on. You have these pairs of factors in this spreadsheet, and that all goes all the way down here to 4800 on the left column and 5000 or 5 kilohertz in the right column. What I have up on the scope is showing a 4 megahertz train of square waves. The Rigol scope is in ultra acquire mode, and it's showing it with multiple trains so that we can kind of see what's happening as I change these frequencies and we go through this demonstration. What I'm going to be doing is using the U-Center software, which is this software here, freely downloadable from UBLOX, and it's the software you use to configure the frequency that you want out of that PPS pin. I won't go into how you do all that, but that other video that I pointed you to has all those details. There's others online that have shown how to do that as well. So what I'm going to do is I'm going to start with the 24 megahertz. I'm going to just type this into U-Center, and we'll go to the maximum output frequency, and we'll take a look at that train of waves. And you can see that there's no glitches in it in terms of any variation in the wavelengths of these square waves, the train of signal. And it is showing a count of 24 megahertz with like 4 zeros after the decimal point. There's a little bit of wandering back and forth because I don't have a GPS lock, and it's relying on its temperature-controlled oscillator on board the GPS unit to maintain the frequency. I'll go down to 12 next. Just have a quick look at that. There's 12. And the next frequency that we would like, it'll be very useful for testing, for calibration, etc., is the 10 megahertz, and a lot of electronic units use as a input, is not available. Obviously, 10 does not divide evenly into 24, so it's one of those frequencies that would result in glitches. So let's type that in and see what that looks like. So there's 10. And what is happening within the UBLOX GPS unit is they have software in there that's working to deliver the desired frequency. And here you can see it's 9.99999 megahertz, basically 10 megahertz. And in order to achieve that number of cycles within per second, if you will, 10 million cycles per second, they have to vary the mixture of 12 megahertz and 8 megahertz waveforms. So that's why we're seeing all this, what would be referred to as glitches or jitter in the output. It's actually just the software saying, I need to deliver 10 million waveforms per second. And this is the way that I can do it, because I can't deliver one particular waveform consistently across that 1 second time period. So I have to mix the 12 megahertz with the 8 megahertz. And so that's what that looks like. Now, if we were to go down to, let's just go down to 1 megahertz and play around a little bit with waveforms that are just off of these safe frequencies, or these evenly divided frequencies. So there we have 1 megahertz. It's showing 999.999. So basically 1 megahertz. If I was to put in 1, so it's 1.01 megahertz. Did I type that in right? 1.01, there it is. So 1.01. So basically 1% of the waves need to be modified or shortened, if you will, in order to get that additional number of counts in per second. So that's what you see here. Some of the waveforms are narrowing. So they have shorter wavelength, if you will, relative to the 1 megahertz, which they can deliver. So you've got the 1 megahertz and the 960 kilohertz being mixed together. And because these are pretty close, they're not as far apart as, say, the 24 and the 12, where we have 6 megahertz of difference. So the waveform or the wavelengths are not that different, and that's what it looks like. So you can deliver the appropriate count from the UBLOX unit. It'll deliver exactly what you type in, but you just won't get the same waveform per second. You'll get a mixture of waveforms in order to deliver that number of cycles per second. So that's how that works. If I let's just change another 0 to a 1. So we'll have a higher percentage of difference. And so there you go. You start seeing glitches happen more frequently, and maybe the difference in the wavelengths is more pronounced between the ones that are being mixed together to produce. Now I have 1.11000 megahertz, which is exactly what I typed into the U-Center software and submitted it to the UBLOX unit to deliver that output. So it will deliver whatever count you ask for. You just won't get the pure waveform unless it's one of these evenly divided frequencies into the 24 million. So that was it. That was the point of this this video, was to kind of demonstrate exactly what's happening. All right, thanks for watching.